Hello again. Just to make things simple, I have just typed to save utilize the time of the video for better explanation. So the constants that are supported by C language are, I have told you, you have I'm talking about numeric constants. So you have integer constant which you have studied. This becomes an unsigned integer. 12L becomes a long integer. 12UL becomes an unsigned long integer. For floating point, we have seen that there is one representation wherein it is scientific 13.45 can represent, or you can also represent 1345, the same number, e to the power of -2. Now coming to integer, by default, if you look at the integers, they are by default to the base 10, but it also supports base 8 and base 16. So just to remind, octal is, you have 7 symbols. 0 to 7 in base 10 is equal to 0 to 7 in octal. 8 in base 10 will be 10 in octal, because this is how it is. 1 into 8 to the power of 0, 8 to the power of 1 plus 0 into 8 to the power of 0. 9 will be again 1 like that. Similarly, if you extrapolate to hexadecimal, it is same. Only thing is the number of symbols is A, B, C, D, E, F. No, not case sensitive here. So if you look at 0 to 15 in base 10 is 0 to 15 in hexadecimal. When I say 0 to 15 is 0 to 9 plus you have 10, 11, 12, 13, 14, 15. Up till that there is no problem. The moment it becomes 16, then it will be taken as 10, because it will expand, right? So let us try and see what the computer has to say. I have written a small code here. What I have done is printf %d, which is 8, which is in base 10, because by default integer call the constants are in base 10, will be in percentage o. Percentage o is to display the octal equivalent of a decimal number. Octal equivalent of a decimal number. Please remember this. So 8, then 9. Similarly, percentage x is to display octal equivalent of a decimal number. In this I am doing that, okay. Not generalized. So percentage o is, I am displaying, when I say percentage o, whatever is here, it will be displayed as percentage o. So percentage x is again an octal hexadecimal equivalent of a decimal number. Okay. So let me just see. Let us just see how exactly will be the output of this. So if you see, 8 in base 10 is 10 in base 8, 9 in base 10 is again 11 is in base 8, that explains it. 16 in base 10 will be 10 in base, etc. So we also have to look at one statement like what happens if I give 7, right? Alright, so let me make this as 7. So if I make this as 7 and then run the code, so 7 in base 10 is 7 in octal. So similarly, let us look at our hexadecimal. So hexadecimal, let me make it as up till 15 it has given, right? So let me increase it to 10 now. So I will, in hexadecimal, I have 10, and let me, I have equivalent of 10. Let me see what is displayed. Okay, semicolon, did we forget? Yeah, did we forget symbol? Yes, it is. Okay, so now so I have, if you look at, see for example, 10 in base 10 will be A in base 16, isn't it? So in this case it can be either capital, small, that doesn't matter, right? So the other vice versa should also be possible. So what I will do now is, how do I tell that it is an octal number or a decimal number or whatever? So let me just reverse this, take this complete thing and reverse it. Okay. So what is the meaning of reverse it? I'll tell you. So here what we will do is, we will say now percentage d in octal 8 in base 8, I'll give percentage o, okay. In base 8 will be percentage D in base 10. We'll do the ulta. So this is our base 10, right? We'll remove this. Okay, so I will remove this again so that it becomes, I will take this. Okay, now we will say percentage O in base 8 will be, we will try and run this code. Okay, so let us see what will happen. Will it really take or will it give an error? We will see. Okay, so we just reversed it. First we have already understood the first one. So what does it say? 7 in base 8 will be 7 in base 10. Any problem there? Okay, there is no problem there. Now for example, I will say 8. Okay, 8 in base 10, 8 in base 8 will be what will be in base 10. So 8 and I will make it as 9 for example. 9. I'll make this as 8 and make this as 9. So our problem is, let us see how this will display. How does the machine differentiate between an octal number and a decimal number? Okay, so then if you see 10 in base 8 will be, okay, 8 in base 10. See, 10. I have given 8 and 8. So my 8 has got converted into what? My 8 has got converted into 10 here. So which is the ulta, which is the reverse of that. Sorry to use the word ulta, so it's like dusra. Suppose if I now give, instead of it did the double conversion, so suppose if I do 0 1 0 now, and here I do say 0 1 1, right? Okay, so let me get the percentage D of 0 1 0 and 0 1 9. 0 1 0 and 0 1 1. Okay, so percentage O of 0 1 1, let us see what is, how it will be taken as. So let me go back to okay. So now if you look at this GCC minus O output 1.c. So now what we have done is, we have given 0 1 0, it is interpreted as 1 0, which is no problem, which 1 0 in base 8 is 8 in base 10, 1 1 in base 8 is 9 in base. So let us, that is taken care of. Let us go back and look at our base 16. So base 16 I use a format specifier called as X. So let me look at base 16 here. I can do the double conversion, so base 16 to base 10. So in suppose if I gave say 16 in base 16, and let me see what will be the decimal equivalent of that 16, and here I will give 17. Let me see what is the decimal equivalent of 17. One way of looking at it. So let me run this code. So when I run this code, okay, so it is nothing but 10 in base 16 will be 16 in base 10, 11 in base 16 will be 17 in base 10, because I have given 16 16. Or I could also say, if I directly want to look at this, I can give 0x what was our 10 and 0x10, okay, and then I'll give here 0x11, I'll give 0x11. Then let us see what it will convert to. The answer should be same. I think I made this 0 or O. I think I made it O. 0. Okay, so it's the same output again. See, the only difference is first time it got it converted automatically. This time we actually made sure that it gets converted. So if at all I want to now declare something, there is a difference. If I say int a equal to 10 is in base 10 straight away, this we should understand. Okay, is different from if I say int a equal to 010, then it is taken as octal. So if I display the value of a and let me close octal a, let me take out this. Okay, so if I now display the content of I have OA, so OA will be now, I'll simply give OA will be now what? In base 8. So let me take OA in base 8. Okay, if I display the percentage D of that, then what it will be? So let me just do this. OA equal to in base 8 equal to percentage D in base 10. Let me just put it this way. So I'll just make it as okay, let me get this fellow here. We have given this, will make it as percentage O, I'm sorry, percentage 0, and here I will make it as percentage D, so which is my OA and A. Okay, so don't get rattled by this. If you just follow the video slowly, you will be able to understand. So if you now look at, okay, so what we have displayed, OA, which is in octal, okay, I'm sorry, percentage O. Okay, so so OA, which is 10, if you look at 010 has been converted into 10 here, in base 8 is equal to, right, 10 so it should be what? It should be 8, right? Oh, I have to just display, I have displayed, it should be OA, I'm sorry. Okay, so nice to have these errors because we are doing extempore. See, OA, which is 010 in base 8 is 8 in base 10, isn't it? So it is recognized like this. So let me take for hexadecimal again. So let me take hexadecimal, int xa, I have to give hexadecimal like this only, 0x, so I will say AA, right? When I do 0x AA, this will be in percentage x in base 8, so I have to just put this straight away, 0x AA, I will put small a, so let's say 0x AA. Okay, let us see what that conversion will be. Okay, now if you see, A it has taken as, so it's not case sensitive, so it is 170 because A is 10, so it is 16 into 10 into 16 to the power of 1, which is 160, 10 into 16 to the power of 0 is 10, which is 170. Okay, so the inference here is when I give 0x AA, Okay, even if it is an integer, it gets converted and stored there. Okay, so it is still an integer type, only the value is represented, the base is actually changed. So C supports base 10, base 16. All right. Okay, I hope you have understood. If you have not understood this, please rewind that video and find out and try and understand. If you still have doubts, please mail me at nitinpujari@gmail.com. The video lectures are extempore lectures, so I don't rehearse them, or there is no script there, so it looks like a natural classroom study. All right, thank you. Hope you understood this video. Next in subsequent lectures. Thank you very much.